Welcome to the One Wire Boards channel. I started this channel 4 years ago and I never did much with it. I've been working with One Wire devices for over 15 years and I've written lots of applications and programs, done a lot of coding, and worked on different designs that I used to control a number of the One Wire chips that I was interested in. I started with the temperature chips, and then I moved on to the DS2408, which is an I/O controller. Which, by the way, this picture has four DS2408s in it because this is something. This is in my attic. Actually, isn't a picture in my attic. This is in the garage, but this is in the attic now. And I'm going to do a video on this one. This one's a lot more complicated. I'm controlling my sprinkler systems, and I'm monitoring my air conditioning system, so I know when the air conditioning system's on and off. I know how many hours the air conditioning system's been running in a month. I know when to change filter. I mean, and I have a whole back-end system that records the data, puts it in a database, and web app that shows it. But the whole purpose today is to go over the One Wire temperature sensors at this site, which is onewire.net. And you can go to this site right now if you want, and follow along with me to kind of get an understanding. This is live. It's on the internet. It's in the cloud. Um, so just a little bit of information about me. I spent 40 years at Raytheon in different roles, and spent my last 20 years in software engineering at Raytheon. I led the Windows Server support team for corporate operations, and I spent many years in software architecture and design. My final 4 years at the company was spent in robotic process automation, RPA, and if basically RPA is where you're programming a desktop computer to do many of the tasks a person would normally do. Um, and so you you replace people. You replace some of the mundane, repetitive tasks a person does, like check emails and look for things in emails and create spreadsheets and create Word docs and these kinds of things. And at the time, the software for RPA that we used was called Blue Prism, so you can look that up. Um, but I'm most interested in temperature sensors, 8-channel input output, and battery management devices that One Wire makes. And this site is all temperature sensor based. As you can see, you can click here and go to the DS18S20 site. That is the data sheet for the chips I'm using. And I do use the 18S20. I don't use the B20 or the 1822. I could. It's just I started with the 18S 20 years ago, and I just kept using it. But it's not like I don't the changing the software is not that big a deal. Uh, so let's take a look at this application. So as you notice, it says today is the 29th of June. The server in the cloud it's 11:30, and this my zip code where this my home is 75056, which is in Texas. So this is showing I've got 8 different temperature readings. Some of them are kind of redundant, and I'm gonna kind of clean up on this since this stuff's all running in the attic. I don't spend much time in the attic. It's pretty hot up there, as you can see. The peak of the attic right now is 123 degrees. The attic, just where you would be standing, is 104 to 105. I also, and the outside temperature today is 93. It's going to be 100, by the way, in where I am today, at my zip code. But the house entrance is 76 degrees. It does an automatic update every couple of minutes, by the way. That's why I just did that. Um, the master bedroom. So I've got 2 air conditioning systems. I've got the living room system, and I've got the bedroom system. Okay, on about a 2,400 square foot house. So this tracks what I did is I embedded a sensor in the wall right at the thermostat. So I'm recording the temperature right at the thermostat in the wall. right behind the thermostat, if you will. I mean, it's practically touching the thermostat. And I did the same thing with the master bedroom. So I had to run wires in the wall and all the three wires, ground, power, ground, and the data line for one wire. I've got a couple of sensors that are monitoring the right around the attic where you're standing up or on the floor. Of course, I've got the attic peak. That's the peak of the roof. I have a very steep roof. Okay, so my roof is from standing in the attic to the peak of the roof is probably 16 feet, 17, 18 feet. So I've got a very steep roof, and so I've got a sensor at that peak area. And while we're doing this little demonstration, you'll see this temperature probably go up because it's getting hot right now, and its temperature's going up. And then I have temperatures. I'm monitoring temperatures in the plenums, and so the plenum obviously is the air conditioning system where the cold air first comes out from the evaporator and it goes into a plenum, and then the plenum distributes through different ducts. It distributes the cold air to the different rooms. So I have a temperature sensor in the plenum that shows it's 56 right now. Let's do an update. Let's do a manual update. And I have one of those in the house system, and I have one of those in the bedroom system. And then if you scroll down, I'm actually calculating the delta T, and that's interesting because the delta T is a great indication of how efficient or how effective your air conditioning system is cooling down the air that is pulling in from the house. So, you know, if the house temperature is 76 degrees, as it shows here, and then the plenum temperature, so that's what's going into the air conditioning evaporator. What's coming out of the evaporator is 55 degrees, so that gives you a minus 21 degrees delta T, which is pretty darn good. 18, 17, 18 is probably normal. 19 minus 19 is probably normal. But anyway, and then just a little more information. All these temperatures are recorded, and they're sent to the cloud and stored in a database, and that cloud database right now has 18 million records in it. So this is recording temperatures every minute. Okay, so every single minute of the day, over 24 hours, it's recording a temperature, and it stores the temperature in a basic temperature database. So all the temperatures are in one table of a database, and then I store the hourly temperatures in another database, so I can easily run graphs and things like that to show hourly temperatures at my house in the different areas where the sensors are. And then I also have a table that stores high and low temperatures for the given. So that's where this high and low information is coming from. So what we have here is we have the location of that sensor. We have the current temperature at that location. We have the high currently at that location. We have the low today at that location. We have the capability to show the last 30 days, which we'll go there in a minute. And then we have the ROM code. This is the ROM code of that sensor. And as you can see, that's across all of them. Let's see what else real quick. So just real quick, so this, I kind of try to keep track of the versions I'm running. So this is a beta version 0.07, even though it's been in production for 13 years. It's really just been a test. It's been there as testing, and it just works great. The cloud I'm using is smarterasp.net, and it's a really good. I really like it. It's very inexpensive. They give you databases, they give you Windows servers, they give you everything that you can get access to and store your code and set up websites, and I'm really impressed with what they provide. And then of course this code of this page is updated on June 24th, and I'm running on Windows. I'm running on a Windows server called Win5165. So first thing I want to show you is let's go change. One of the things you can do is you can control the decimal places. So I'm going to do $D equals 1, and now I'm getting an additional decimal place. Okay, so these temperature sensors are accurate enough for 1 decimal place. Okay, so most people are used to temperatures on thermostats and stuff, just a single number, no decimal but you can display decimals on this to one decimal place, or even more if you want. But the more decimal places it's not that accurate to that decimal place, even though it's showing it. Okay, so then you can also take a look at show the last 30 days of a temperature. So let's take a look. This is outside. No, let's take a look at an interesting one. So the attic peak. So let's show the last 30 days of attic peak. Okay, and again, it displays the ROM code. And by the way, the ROM codes are read from right to left. Okay, just like binary. Binary is read right to left. This is a hexadecimal code, so hexadecimal is read from right to left. So in this case, 10 is the DS18S20. That's the code name identification of that sensor. Every one-wire sensor has a code that defines what it is. So 10 is the DS18S20. So here you can see today, that's today, we don't care about today. Yesterday, the high in the attic peak, 136, 137 degrees. Look at this. Tuesday is 141. We had 105 degrees, that's forecast, or 104 degrees forecast. And of course, forecasts are kind of forecasting actual temperatures. When you go to the internet and go to weather.com, and they give you a temperature, you don't know where that temperature is coming from. I mean, they say, oh, it's 89 degrees outside, and it could be 95 at your house, or it could be 85 at your house. I mean, typically temperatures from the Weather Service come from airports, but they don't have to. They may come from a municipal center for a city. It just depends, but whatever temperature is being displayed on weather.com for 75056 is not probably the temperature at the house where I am at 75056. So anyway, but yeah, look at this. So on Monday, 143, 144 degrees in my attic. The attic gets hot. And of course it really puts a bunch of stress on my air conditioning system. So, and this goes for 30 days, so you can look back for 30 days and see this is all coming out of the database, and it's refreshing. And at the very bottom, you can go home. Now notice here I've got some 185s. So I had problems with, and here's another 185. So that's a one wire chip error, and it can be caused by a number of things, and we're not going to get into that right now. But um, I did make some changes in this system that I'm not going to go into today, but I did make changes in this system. So I started to have problems with this system last year, in June of last year, June 2022, where the system would just stop working totally. And it would stop working when it got really hot in the attic, and like 110. If it got over 110 degrees in the attic, the system said, "Nope, I'm not gonna function anymore." And remember, this is after running almost perfectly for 10 plus years. The problem finally boiled down to, and it took me a year to figure it out. The problem at this time right now, the problem boiled down to I just had too much wire up there. Because one of the things you have to remember about one wire is it's all wire based. I mean, you're running wire from one sensor to another sensor to another sensor to another sensor. So it's called the one wire network, and you're kind of like daisy chaining. And so you don't want to put more wire in the connections between each sensors than it's absolutely necessary. And that's one thing I was doing, because it was hot in the attic, and I was adding more sensors, and I didn't want to. I just threw the cable up there, and anyway, we're going to get it. We'll get into a lot of that in a future one wire where I come in and describe exactly how I built this system. But yeah, so right now that's everything I wanted to cover. You can kind of play around with this site, keep an eye on it. Again, the sensors are all the DS18S20s, and they work great. I mean, except for the problems that started last year, which I hopefully have resolved now. The site and what I'm doing and how I'm doing is extremely reliable, and we've got a lot of cool stuff I'm planning So stay tuned, and keep an eye on for more of the sensors coming up, and more of the videos coming up to cover the sensors on the OneWire board.net channel. Okay? Thank you.